If a lattice rectum of an ellipse subtends a right angle at the center of the ellipse, then write the eccentricity of the ellipse. So let us consider the standard form of an ellipse. X square by a square plus y square by b square is equal to 1, where a is greater than b. So lattice rectum is nothing but 2b square upon a. The length of lattice rectum is 2b square upon a, and eccentricity E is equal to under root of 1 minus b square by a square. So let's take the diagram. The lattice rectum is nothing but a line which is drawn perpendicular, passing through the focus and perpendicular to the axis of an ellipse. Let's consider this is L and L dash are the endpoints of the lattice rectum, and this is perpendicular to the x-axis, that is axis of ellipse, at the point focus a, 0, and this lattice rectum subtends a right angle at the center. So we can say that here L dash angle L dash is nothing but 90 degrees. So it's a right angle triangle. Triangle L dash is a right angled triangle. And we can also say that OL is perpendicular to OL dash. And we know that the ends of lattice rectum are, since the length of lattice rectum is 2 times b square upon a, ends of lattice rectum will be considered AE, since the focus it is lying on the line x is equal to AE, 0. So the AE, b square upon a is one end, and another end will be taken AE, minus b square upon a. So that the slope of OL into slope of OL dash, which is equal to 1, since they are perpendicular, and since our center is origin 0, 0, so slope of OL will be taken b square upon a divided by AE into slope of OL dash will be taken minus b square upon a divided by AE, which is equal to minus 1. Upon simplifying, so we can write here so we'll be written here b power 4 upon here a square, here a square, that is a to the power 4 into e, which is equal to 1. So or else we can write or e square here, sorry. So b power 4 upon a power 4 is equal to e square, and we know that e square is equal to 1 minus b square by a square. So let us substitute here 1 minus b square by a square, so that we can write here b square by a square whole square plus b square by a square minus 1 equals to 0. So for some time let us consider b square by a square is equal to say some p to solve this one. So it will be p square plus p minus 1 equals to 0, so that p is equal to minus 1 plus or minus under root of b square minus 4 into 1 into minus 1 divided by 2a, so that is minus 1 plus or minus under root of 1 plus 4, that is 5. So divided by 2, since b square by a square is positive value, so we consider that p is equal to minus 1 plus root 5 divided by 2. So that is b square by a square is equal to minus 1 plus root 5 divided by 2. So eccentricity E square is equal to 1 minus b square by a square. So we can write 1 minus minus 1 plus root 5 divided by 2. We can write this is 2 ones are 2, 2 plus 1 that is 3 minus root 5 divided by 2. So let us multiply and divide with 2 so that we can write here 6 minus 2 root 5 divided by 4, so that we can simplify here. We can write it as e square is equal to 6 can be written as root 5 whole square plus 1 square minus 2 into root 5 into 1. So the numerator is root 5 minus 1 whole square and denominator it is 2 square. So we can write e is equal to under root of, so this is root 5 minus 1 whole square upon 2 square. So eccentricity we can write it as root 5 minus 1 upon 2. So eccentricity for the given ellipse is root 5 minus 1 upon 2. That is the answer. Okay.